Hello, welcome to another devlog for my 2D space game. In the last episode, I decided to start drawing all the shapes like this because I found that when profiling the code, we spent a lot of resources drawing the shapes when we filled in their space because we currently have 100 of these boulders spread around the planet and I didn't want the game to be lagging. Sleeping on this, I'm realizing why was I even able to see that in the profiler? And after some investigation, it means that they're checking it in the CPU, I think. And I think that should be happening in the GPU. But then I thought like, why isn't Arcade doing this more optimized? But that's because I'm not even using Arcade. I've been using Pymunk's shapes, and then just when I'm drawing, I'm making a single draw call, and that's slow. So apparently, there's this thing called a shape element list that Arcade provides. A list of shapes that can be drawn together for better performance. But then it says if you need to move a lot of shapes, it's better to use Piglet's shape system, and that this is only suited for static shapes. And I'm not sure, does that mean, is that what I'm using currently? I don't think so. Okay, this is pretty confusing. So it seems like there are 3 different types of circles. Well, 4 if you include mine. But we have Pymunk's circle and we have Piglet's circle. And then we have also Arcade's version of a circle, which is represented as an ellipse. This is a bit frustrating. It's so convoluted. Like, why is there not just one single class for this? But I'm sure there are good reasons for that. Anyway, so what if we make the drawing use Piglet's shapes? Because last episode I briefly investigated using sprites, but I'm not too big of a fan of that due to the resolution issues, and it just seems a bit unnecessary. But what if this is going to be much nicer, and then you draw this in batches? So we have the Pymunk circle for the physics, and then we have the Piglet circle for drawing. So I'm just trying to get this working, and we got something drawing. So circles are hard-coded to be drawn with 20 segments. We could turn that up here, and we have some issues here. Oh, I feel like it's rotating not around its center when we set the angle. What options do we have here? This is pretty interesting though, because it's drawing everything so much faster. Not even changing these to circles now, we're just drawing all the vertices. So this is very exciting. If I can get this working. I wonder, will we be able to change the color after the fact? Oh, yeah, maybe. Nice. Okay. I should have done this from the start. But yeah, I feel like the coordinates they're not centered. They're centered on something differently. I wrote the center vertices on corner function, but I don't think we'll need it. It's enough to just change the anchor position of the piglet shape. Because the vertices we supply here, I believe they are transformed, so they're never negative. But the vertices unedited are centered on 0, 0, so they're gonna have negative coordinates. So to combat that, I just changed this to use the corner as the anchor position, which I think is right. No, but that's the maximum. It might be the negative minimum corner instead. I think that's better. Then we have these rotations being wrong there, or not rotations, the triangles are wrong. It's better though. But let's see. I wonder if we got the angle wrong there, because when we were drawing the sprites, we had to negate the angle degrees. Nope, still not right. Well, it should be called max. Let's change this. Some ugly code here. That's fine for now. It's definitely not that. What if we remove that then? Then it looks like this. It's a bit better, but I liked it more. What the heck is happening? Why can't you take negative coordinates? This is very strange. I feel like the best result was using the minimum there, which is what I expected, but then we have the triangles aren't matching up. But they're aligning perfectly there though. Is it something like using maximum of one and the minimum of the other? Well, I guess we have more to try here. Then we can also do this and this one. Nope. Why is it never easy? It's so close though. And it renders so quickly. Yeah, I really want to get this working. It's only these. Is it the way I create those? Oh, wait, when I create them from world points, I might not be setting the center position properly. Vertices unedited position. I take the average position. Oh, so I do try to set it. What's the average position in a triangle? Like there? It's like up there. But I feel like this is a telltale sign that it's somewhat working. Oh, is it just like this? Pause. Wait, just added? Wait, what was it before? If you try this minus this, this is properly implemented, is it? The hell is this code? Oh, because I need the length of it. I think that's how you do an average of vectors. Does it have to do with the rotation on these things? What is this? So this might be explaining it. So the rotation for the piglet shape, the shape's first vertex of the shape. What the hell? So that's the anchor position. So it rotates around the anchor position, but 0, 0 is the first vertex. Okay, so that just means I have to change the anchor based on the first vertex, not the minimum or maximum corner. Okay. Oh my god, finally. Okay. Oh, that sucked so hard. So now it's working and I can finally clean up. Don't need to show the position debug anymore. This was the correct rotation, same as for the sprites. But the big trick is to set the anchor position to the negative of the first vertex, since all my vertices are already centered around their average. Let's just try this real quick without the debugging, and oh yeah, it's so much faster. Ah, my god. So I feel bad for anyone who's been watching this and actually know about this stuff, about the inefficient way I've been drawing the shapes, because this is really amazing now. It's very messy at the moment. I'm gonna clean it up. I was pleasantly surprised to see that we can draw the entire planet. We tried this before with the old drawing method and it was super slow. Now it's no problem. But then I'm noticing this, like the collision is down there, and it turns out that Pymunk's poly that we use for the collisions has to be convex, and so we can't have these kind of corners, I believe, is the issue. So it seems we have two options. This is really territory that I don't know much about. I've been getting a lot of help from AI here trying to explain this. So we could either split up the concave hull into multiple convex hulls, and then we feed those to Pymunk. But like when I gave the planet, for example, it generated 47 convex hulls, and that seems like it's going to be pretty inefficient. So then I was thinking, well, what if I make the boulder method only generate convex shapes? And I thought about that for 10 minutes, and I'm like, how the hell does that work? And it's pretty complicated. So got some crisp AI code in place. This is all from Gemini 3, and it's using something called monotone chain algorithm, which is pretty interesting, and it seems to work. So let's run this, and it looks like this. So this is pretty exciting stuff. Now all the collisions work beautifully, and we have these boulders here that are all convex, and look at our frames, pretty much stable 200, and this is so cool. Like, these are fully acceptable boulders, and I think it makes more sense that they're not concave as well, because very rarely you see concave boulders. They're usually convex, because if there's a point sticking out, is that how it works? I guess if it's an indent, if it's a pit, I guess that is a bit common, but then if there's a pit, there's going to be a peak, and the peak is going to be worn down over time. So I feel like these look more natural. But look at the planet. It's really cool. So I was playing with the idea, like, what if we stop using circles? It would give us, because right now I try to make everything work for circles and polygons, but it's like it's twice the amount of work. This kind of gives us like some more interesting shapes. But then, for example, a sun or a star should probably be a circle. But I don't know. You get these interesting gradients here. Like if we put a circle there, it's gonna start rolling down. I mean, which is kind of cool. It's like it's a hill, right? So then, of course, if we turn down the noise, it's gonna be very circular. This is very interesting. I really like this convex boulder code from Gemini. I'm gonna keep this and clean it up and probably move it to utilities. I'm a bit afraid of what people might think when I'm using AI code like this. But I think it comes down to what I think is fun. It's about the balance. Like, I'm not gonna have the AI write the whole thing. I want to understand what's happening and do most of it. But then certain complicated things that previously would Google, find a Stack Overflow answer and adapt it to your code anyway, and that's the same. You just copy someone else's answer on Stack Overflow. AI is the same thing but more sophisticated. But I understand, like, there's a lot of worry about AI replacing us, so I get that there's a lot of emotions involved. But I'm generally very pro AI, but I want to use it responsibly, I guess. And I think most people probably use AI more than they'd like to admit. And it's probably gonna change in the future. We don't really know what's gonna happen, but having access to stuff like this is very interesting. I'll just try and be transparent. I guess that's an important thing, like not pretending that you wrote the code that AI wrote. So my approach is just being transparent and not claiming credit for something I didn't do. Actually, reading through what Gemini had made for us here, we're still generating the points like before, but then it's just removing all the points that make it concave. And that's why we see these long stretches of flat. Like, it's not gonna enforce the amount of points. So I wonder, I'm gonna ask it to see if it can keep the amount of points the same. This is insane. It's thinking so much. I feel like it's stuck in a loop. This is the new Gemini 3. Oh, here we go. Did I click something or did it finish? Alright. Subdivide the longest edges of the resulting hole until... Oh no. Then it's still gonna be straight. Poor AI. This seems like a very complicated issue. My god. Yeah, no. That's not what I want. Okay, so maybe it's good enough. Reach the thinking limit. Need to push the new midpoint outwards slightly. This breaks the perfect straight line. Okay. That sounds a bit more promising. So when we have the straight lines, it pushes it out. Let's commit here so we can have some history in place. Working random convex boulder, very straight. So it's gonna go here and like that and like this and this. Well, that didn't work. The noise might be a bit much. Yeah, no. Okay. Anything I can fix? Probably not. Got the random points there. We filter and then we subdivide. So it's probably in here, the subdivision. The subdivision is just hard-coded here. But this is just what I was doing in the beginning. This is not gonna give us convex shapes. Yeah. Okay. So let's go off the one we have here. But I think I wanna support circles as well. But time to clean up. Might be good to check how it feels to drive on this kind of surface. Oh, brake, 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 brake. So the camera is aligning to gravity, I think? No, it wasn't. Okay, so this is pretty flat here. Push. Okay, let's move you. Thank you. So here's the corner. Yeah. Ah, this is kind of nice. Give some more character, and then like some planets are gonna be more uneven than others. And it's gonna give us like slopes and stuff. I'm sure we can figure out a way to visualize how flat something is as well. So like imagine you're orbiting this planet and you want to find a nice flat spot to set up your base. Yeah, that's definitely possible. I'm liking this. Alright, I've cleaned up the code and even got the coloring working again. So now we're drawing all these shapes with piglets batching, and it's so much faster. My god. Still drawing these orbital lines with the old system. So that could be something to port over as well. But otherwise, I'm pretty happy. Oh. Okay, so I think the issue is when we create these boulders, we only change their cost, but not their worth. We just put worth as well. No, boulder module. Oh, we're changing the cost of the base class, but then it can't recalculate when we resize it. Yeah, they should belong to the instance. But I remember I tried that. I couldn't get it working. So I think this should fix that little issue. When we instantiate the module, we store the cost in the instance, because this is otherwise stored in the class. Then I updated the calculating cost method to use the instance instead of the class. So that should let us change the cost of the class before we set the module. This is a fun possibility. We can get a boulder spawning inside, so now we get all this stuff for free. But let's turn on God mode and see if we can resize this boulder. Yeah, very nice. Pretty fun. So if you manage to get this inside and you have these resources on hand, then you should be able to like make it larger or smaller. Always gonna be able to make it smaller if you have space. But yeah, as I was saying, I'm pretty happy with the changes to the drawing. This is much more efficient now. And we got the coloring working well. And for the circles, I still have the old way to draw a line so that we can see how they're rotating. I tried doing this with the new system, but changing the thickness in a piglet line messed up the vertices. it was not good. So I'm just doing this with the old system, like I said here. Another small fix was this. I had disabled the caching for getting the hook methods. This is my own implementation for the dynamic hook system. For example, we have onDraw. So we just, in the top class, we just call the hooks for onDraw. And that calls all the definitions in any of the subclasses. It's a lot of subclasses. But this is expensive, and I knew that, so I put a cache on it. But then in the previous episode, I showed how I had a memory leak when we were calculating this, because I rapidly create and delete the shapes. You can see our FPS is dropping quite a bit when we open this menu. That's fine if it's temporary. Not ideal, of course. We could probably improve it, but whatever. And having this cache prevented the garbage collection from cleaning up those deleted shapes. But I just found that I can clear the cache after deleting, and that frees up the shape for garbage collection. So very nice. We can see, yeah, stays steadily 127 there. And if we disable the cache clear, open that up, we can see the memory leak in progress. Very nice. I have my assistant helping me, and I just fixed this one issue where we couldn't create shapes while the game wasn't paused. Or like we could, but then they would spawn in a weird place, especially if this body moves very fast. But now I'm really recalculating it when we create them, so we get the shapes exactly where we right-clicked.